You're listening to Conferences Online Allergy from Children's Mercy Hospital in Kansas City, Missouri. Today is October 27th, 2025. We will be starting our more advanced immunology course with the BOSS Chapter 1. This is presented by Dr. Nikita Raje, an Associate Professor of Internal Medicine Pediatrics and is the Section Chief of Allergy and Immunology at Children's Mercy Hospital, Kansas City.
Start our discussion about a BUS textbook. I just realized I had been checking all through spring and early summer to see when the next edition is coming out, and it's finally out. So I have the new edition that I'll be working on, and it's definitely a lot of new information that I'll change from last year. Whatever chapter has some more information to add, some of the figures or tables change, and so or maybe just the information is rearranged a little bit. But I'll try to follow the new edition. The first years, I understand, don't have the textbook, but I still decided to go ahead today with the chapter 1 because really the chapter 1 is very much an introduction that we have already gone through with Sumparak, maybe a few more details. But then I'll update you guys on the new edition. The second years already have the 10th edition. So I'm gonna again update you guys, but it might be enough for what you guys have so far. If you guys are interested in buying the new one, absolutely go ahead with it. I'm not sure if your book money allows you that, but I'll also talk to Dr. Miller and update you guys on that. But this is like absolutely brand new. I just found out 2 days back when I was starting to work on a bus, and I was like, oh, there's a new edition. So didn't have too much time to get those textbooks for you guys. All right, so here are my disclosures. Again, nothing relevant to the talk today. We'll be talking about the types of immunity, differentiate between innate and adaptive immunity, and then recognize the role of humoral and cell-mediated immunity. This is just the outline for today's talk. And then a couple of questions here. We'll come back to these at the end of the chapter. Which of the following statements is true? Phagocytosed microbes are killed by antibodies. Intracellular microbes are killed by humoral immunity. Antibodies can eliminate the reservoirs of viral infections, or extracellular microbes may need cell-mediated and humoral immunity. Which of the following is a distinct feature of innate immunity? Diversity, memory, non-reactivity to self, and then specificity to individual microbe. All right, so what is immunity? So the word immunity comes from the Latin term immunitas. That was really, it meant protection from legal prosecution that was offered in Rome to the senators. In health and science, immunity has really meant the protection from disease or infection. And this immunity or protection is provided by the immune system, which means this comprises of the cells and molecules that are responsible to provide that protection. So what's the immune response? It's the collective and coordinated response of the cells and the molecules of the immune system to the introduction of foreign substances. And it can also be defined in a different way to say that's the reaction to the molecules of microbes that are recognized as foreign or abnormal, regardless of the physiological or pathological consequence of such a reaction. So the physiological or pathological consequences can be different types. If there is defense against infections, it's helpful against all so either it's the immune response to the natural infection or to the vaccination, but regardless of those, it will help in protection. Similarly, it can defend against tumors. However, as well as it can help with the repair of the damaged tissues in case of injuries or damage. However, it can cause some pathological issues, such as immune response can be the cause of allergies or autoimmunity or inflammatory disorders. Or the immune response can be a barrier to the transplantation or gene therapy. Um, but that's not the physiological function of the immune system. So, how effective is the immune system in terms of the effectiveness of vaccines that are provided? So, this is just a table that's showing since the vaccines have come into play, how many more cases have been there. Specifically, it compares the previous numbers to 2019 data, and you can see uh, in 1990s there were several cases of various infectious diseases, and those numbers have definitely come down for each of these. And then this table added this new information about COVID-19, where it shows the number of cases in unvaccinated patients versus vaccinated patients. All right, so there are two types of immunity: innate and adaptive immunity. Innate immunity is natural or native, and it's fully functional even before an infection starts. It's hardwired, already in place, and it's same with repeated exposure. And then it's specific for the structures that are common to a group of related microbes. Compared to adaptive immunity, this is acquired or more specific immunity that relies on the exposure of the infectious agent. And it increases in magnitude and its capability with each of the successive exposure, as well as it is specific to a specific structure, even in the same microbe. So the adaptive immune response to the different antigens, for example, on the surface of flu virus, may cause a different response. It also has a property of memory that we'll talk about. And the vertebrates have adaptive immune system. So this figure here shows the different components of innate and adaptive immune system. Adaptive immune system is formed by B and T lymphocytes, whereas the innate immune system is made up of different types of cells and molecules that we'll talk about. It shows the timeline from infection, which means the innate immune response can be activated pretty quickly within hours, just because it's already in place and functional before the infection occurs, whereas the adaptive immune response comes after the infection starts and can take days. Here, this table shows the differences between innate and adaptive immunity, and how each of these characteristic is different. For example, the specificity for innate immune system, as we just talked about, is shared by groups of microbes or molecules compared to very specific response in adaptive immune response. So the innate immune response is less diverse compared to adaptive immune system, where there are these antigen receptors that are generated by recombination of gene segments that gives high variability in the different types of antigens it can bind to. There is some memory for innate immune system, but it is very much expandable and larger in terms of the adaptive immune response or adaptive immune system. Both innate and adaptive immune systems do not react to cells, which is a very important property for both these systems, because regardless of which immune response in terms of self or host cells, if it occurs, can cause a lot of damage. All right, in terms of innate immunity, this is provided by physical and chemical barriers, which is the first line of defense, which means it includes the skin, mucous membrane, and all those epithelial layers can have antimicrobial chemicals in them. Whereas the cells of the innate immune system include phagocytic cells like neutrophils and macrophages, other leukocytes like eosinophils, basophils, innate lymphoid cells, including natural killer cells, dendritic cells, mast cells. All of these cells are part of the innate immune system. There are some protein components such as complement proteins, toll-like receptors, or pattern recognition receptors that we'll be talking about in the coming chapters. So the innate immune response, with all these components in place, is provided in two different ways. Our innate immune system uses two strategies. One is all these leukocytes are used to produce inflammation, and then the other strategy that an innate immune system uses is antiviral response. This could be by blocking viral replication or killing the virus infected cells. Moving on to adaptive immunity. Adaptive immunity is provided by lymphocytes and their products. So these lymphocytes are either B or T lymphocytes. And then the adaptive immune system has these specific features that we'll be talking about. So the first one is specificity. So again, going back to the same concept, the response is specific to a distinct antigens or different portions of the same molecule, right? So the part of antigen that is recognized by individual lymphocyte is called epitope or determinant. And so these two terms are interchangeable, whether it's called epitope or determinant. It's the part of the antigen which comes in contact with the lymphocyte and is able to interact with those antigen receptors on these lymphocytes. So there are groups of lymphocytes that have different specificities so that they are able to recognize and respond to different foreign antigens. The clone of, and those groups are called clones. So the clones of lymphocytes that are able to recognize a particular antigen causes that clone to be selected, and that process is called clonal selection. And once that clone is selected, it undergoes proliferation. So those cells that are specific for that particular antigen are the ones that will proliferate, and all of those cells that are produced will have identical receptors, which means they will have identical specificity. And that's called clonal expansion. So this figure shows that clonal selection. Here is a precursor that makes different types of lymphocytes. Each of these lymphocytes has a receptor. So if you look at the shape of these receptors, it's different, which means it can bind to the different structures or antigens. And so each of them have a different specificity. When this lymphocyte is going to come in contact, any of these lymphocytes, when they come in contact with the antigen that they can interact with, those are the only lymphocytes that proliferate. So here, this purple one was able to interact with the antigen that it was specific for. So that clone or group of lymphocytes will get selected. That's clonal selection. And once that selected clone proliferates and make more number of lymphocytes with the same specificity, they'll make this big, huge group called the clone and is able to produce antigen-specific immune response. So that's called clonal selection. Another feature is diversity. So because there are all these different types of specific receptors or clones of lymphocytes, there are multiple clones in place so that they are able to recognize a large number of antigens. Due to the variability in the structures of antigen binding sites on those receptors, right? So all the different clones come together to form what is known as the lymphocyte repertoire, which means the total number of specificities that the lymphocytes in an individual can interact with gives the number of different types of lymphocytes that are present in that individual. That can range from about 10 million to 1,000 million of these different specificities for these lymphocytes. So that provides a diversity in adaptive immune system. Another feature is memory. The exposure of the immune system to a foreign antigen increases its ability to respond again when it comes across the same antigen in subsequent exposure. So the next time the exposure occurs, the response that comes is different, and that's called the secondary immune response. It is more rapid, it is higher in magnitude, and it's qualitatively different from the primary response or the first response. This is due to the long-lived memory cells, and these cells are more efficient that can give the secondary response. So let's look at that response here. There are few features that we are looking at. One, that there are different clones of lymphocytes, but when there is exposure to a particular antigen, say antigen X, there are only specific lymphocyte clones that will respond, which are that clone that it can interact with is the one that will get selected. And that will be able to produce a primary anti-X or that antigen response and provide the immune response. Now, if there is a re-exposure to that antigen, in that case, the secondary response is going to be different due to the memory. So here we saw the specificity. Here we are looking at the memory, that the antigen X memory was kept by the immune system, and the cells, memory cells, provided a higher magnitude and a faster response to that particular antigen. But that is so specific to that particular antigen that if there is exposure to a new antigen at the same time, the response to that antigen, say antigen Y, will still be a primary response just because it has not been exposed to it previously. And then as the immune response is able to clear the infection, the immune response contracts and the immune system comes back to homeostasis. So all these features are seen in this one figure. Another feature is non-reactivity to self, which means that there is an ability of the immune system to recognize and respond to and eliminate the non-self antigens, but at the same time not react to self antigens. So the immunological unresponsiveness of the cell to the self antigens is called tolerance. And the tolerance is due to various mechanisms. There is elimination of self-reactive lymphocytes during their development. If those develop regardless, those can be inactivated, and if not inactivated, there is still suppression of the self-reactive lymphocytes by regulatory cells. So that's your non-reactivity to self. All right, next slide here. All right, so now moving into the different types of the adaptive immune response. So we talked about the innate immunity, we talked about adaptive immunity. Now we are talking about different types of adaptive immune responses. These are two types, humoral immunity and cell-mediated immunity. And as we know, the adaptive immune response is provided by B cells and T cells. And to keep in mind, the B cells that provide the humoral immunity will be able to mount a response to extracellular microbes. So microbes, when they are in their extracellular phase, is where the B lymphocytes are able to use their mechanisms, or if the effector mechanism for B lymphocytes, as we know, is secreted antibodies, and so they are able to respond to the microbes in their extracellular phase. In terms of the cell-mediated immunity, there are two different types of cell-mediated immunity, where so the immune response that comes from helper T cells is provided by phagocytes, and that is provided against the microbes in their extracellular phase. Whereas if the microbes are in intracellular phase, or these are obligate intracellular microbes, the T lymphocytes, called cytotoxic T lymphocytes, will provide that cell-mediated immunity. All right, so this shows the different types of effector functions of these lymphocytes. B lymphocytes use their antibody mechanism and help in neutralization of microbes. They can tag the microbes, and then help with that phagocytosis and complement activation. Helper T cells, when the antigen binds to the T lymphocyte receptor, these T lymphocytes can interact with various cells in form of these secreted molecules called cytokines. And the helper T lymphocytes can make different types of subsets of helper lymphocytes that provide different types of cytokines and can help in activation of macrophages, cause inflammation, help other T and B lymphocytes in their job as well. Whereas the cytotoxic T lymphocytes will interact with the target cell or the infected cell and kill that infected cell. The regulatory T cells, they respond to the activated immune system and bring back the immune system to homeostasis by suppressing the lymphocyte action. All right, moving on to another type of classification of immunity. So we talked about adaptive immunity and innate immunity. Here we are classifying immunity as active and passive immunity in terms of how the human body can react to different and get immunity in different ways. So active immunity is produced when or induced when there is exposure to a foreign antigen. So that is the natural immunity once the infection occurs. So that response of the immune system is specific to that antigen, as well as it forms a memory that can last for a long time. Compared to the passive immunity, which is basically transfer of the immunity that also results in recovery, and it's very specific to the antigens or the antibodies that have specificity for certain antigens, but there is no memory that is present after it is once the passive immunity is out of the system. All right. Moving on to the last little bit of discussion about the immune response to microbes. So we talked about the innate immune response and adaptive immune response. So the initial immune response is provided by the innate immunity. The first line of defense is the physical barrier that provides just the physical barrier, as well as the antimicrobial chemicals that provide the properties of those chemicals are able to kill some of the microbes right then and there. This occurs at different places such as skin and different GI, GU, respiratory tracts where the physical barriers are present. The innate immune response in terms of cellular immunity is provided by different leukocytes. So there are these cells that are present in the tissue. So say if the physical barrier, the first line of defense, is broken, then the microbe or the foreign antigen is going to come across sentinel cells that are present in the tissue behind these physical barriers. So these are dendritic cells, macrophages, mast cells. These sentinel cells are watching out for any kind of invader, right? Once there is an invasion, these cells will produce cytokines. Those cytokines send messages to the blood circulation saying we need help, and the first responders, which are the neutrophils and monocytes, eventually will be recruited from the blood to go to the site of inflammation or breach of that barrier. And these cells also start fighting the microbes themselves. So that's the inflammation strategy of the innate immune system. The second strategy that the innate immune system uses is the antiviral defense, which is provided by cytokines called interferons, and they prevent the viral replication. And then there are these natural killer cells which help in killing the virus infected cells. So that's your innate immune responses from the cells. The other part of the innate immune system is complement proteins. There are other proteins that also provide similar innate immune response. And we'll talk about that more in future next few chapters. All right, so we are moving to the adaptive immune response now. Adaptive immune response, as we know, starts with infection. Once that infection occurs, the antigen, the foreign antigen on that microbe will come across the lymphocyte antigen receptors. So that could be a naive B cell or a naive T lymphocyte. And once it is able to interact with the lymphocyte that's specific for that antigen, the clone that gets selected will proliferate. So there will be clonal expansion. Once it's a good sized clone, those lymphocytes will undergo what is known as differentiation. And so these naive cells are cells that have not come across antigens. Once they come across the antigen of their specificity, they get activated. So they are no longer naive cells, then they are activated T lymphocytes or B lymphocytes. And as they proliferate, they are going to undergo differentiation. So they differentiate into their effectors mechanisms. So the B cells become plasma cells, or the T cells become either a subset of T helper lymphocyte, or the CD8 cells or cytotoxic T cells become the CTLs that are now ready to be able to kill the microbes. With those effector mechanisms, these lymphocytes, B and T lymphocytes, will fight that infection and clear that infection. As that antigen starts getting eliminated, that immune response is going to start to go down, so that the immune response is going to start to contract. Most of these lymphocytes are in that process going to die, except for a few that will be left behind, which are called the memory cells. And that will continue to stay in the system to provide that memory if there is re-exposure to that antigen. So that's your adaptive immune response. A little word about cytokines. These are secreted proteins with diverse structures and functions. They regulate and coordinate the activities of the cells of the immune system. They help in growth and differentiation of immune cells. They help in activation of the lymphocytes and help in the effector function of not just the lymphocytes but other immune cells as well. And they help in regulation of cell migration and movement. The specific type of cytokines that help in regulating the cell migration and movement are called chemokines. All right, that was it. We'll go back to our post-test questions. Which of the following is a distinct feature of innate immunity? Anyone? What's the most notable feature?
C, non-reactive resolve, since all the others would be adaptive immunity.
That's true. So that's the most distinct feature of innate immunity. The others, there might be a little bit of version of the innate immune system, but they are more relevant to this adaptive immune system. Which of the statements is true? I'll let you guys read it.
I'd go with the
You said D?
Yeah, D. I also
Okay.
agree.
Correct. So, so the phagocytous microbes are typically need the phagocytosis and the cells that kill those microbes. Intracellular microbes are the ones that are not accessible to humoral immunity. Antibodies can act in the extracellular phase, but the reservoirs of viral infections will need cell-mediated immunity. And then the extracellular microbes are the ones that can be dealt with by both cell-mediated and humoral immunity. All right, so that was the last slide.